In the last two sections of Chapter 3, we're going to be looking at things called an annuity. In finance, the term annuity refers to a sequence of equal periodic payments. So things like $100 a month, that's an annuity, $50 a week, $500 a year, these are all annuities. Technically, there's two kinds of annuities. The ordinary annuity is the one where the payments are made at the end of a compounding period, and the annuity due are payments made at the beginning of the compounding period. We're going to be taking a look at ordinary annuities in our chapter, and we don't do the annuity dues. You can figure that one out later if you need to. However, here is a situation where we have an account. We're making regular deposits into the account, $100 at the end of each year. And here's an example of how that works. Here's a timeline. Today, we are opening our account, yet we are making no deposit. There's zero money in the account today. However, 1 year from now, we're making our first deposit, and that's the $100. That $100 is going to gain interest over the next 4 years. Using the compound interest formula, that $100 amounts to $136.05. Now at the end of the next year, we make another $100 payment. That $100 payment is going to earn compound interest for 3 years. Then, at the end of the next year, we make another $100 payment, and so on. So as you can see, each payment is earning interest at a different rate because it's a different amount of time. And so the last payment, adding all of those up, gives us the sum of money that we would have at the end of 5 years. Well, that's the idea of the ordinary annuity. What we want is one formula that does all of this calculation for us. And so the one formula looks like this. The quantities R, M, T are the same as in the compound interest formula. We've got two new variables, PMT. Now that is not a P times an M times a T. PMT is used to represent the quantity payment. We have issues in doing this on our calculator because you can't have a PMT for a variable. We'll probably just call it P. However, it's called PMT in most formulas like in your book. The future value, FV, stands for the future value. And again, that could be called by a single variable, but that's the way it's used in the book. And so let's see how we would do the formula. In this problem that we were doing in the beginning, which we've already done manually by doing the compound interest formula 4 different times, we're going to see how we can do it in one calculation. We deposit $100, that's our payment. The interest rate, 8%. Now that goes in both places where the R is. The time is 5 years. The method of compounding, notice the M is in 3 different spots. And the compounding is annually, so the M is a 1. Now, much of this we could do in our head, but I want to show you how to type the entire thing with the appropriate parentheses. Look at where I've put parentheses. When you have a fraction, all of the numerator has to be in parentheses, all the denominator has to be in parentheses. The exponent, if it's more than just a single number, needs to be in parentheses. And so here we type it on our calculator like this, with the extra parentheses that I've inserted. You need to figure out how to type these onto your calculator. Here's another situation. We've got $500 deposited regularly. We want to know how much is in the account after 10 years. So it's very similar to the problem we just did. We use the formula. Now to find out the interest, we'll do that after we find out how much is in there. And so let's plug all of our numbers in. And again, the proper way of typing this on the calculator with all the parentheses in the right spot would look like this. And here's what we get for the future value. So $500 a month for 10 years in this account would give us $84,895.40. Now, how much of that is interest? Well, the interest is the difference in the amount we actually deposited and the amount we have at the end. How much did we actually deposit? Well, we deposited $500 a month, 12 months a year, for 10 years. Multiplying that out, we got $60,000. So if we deposited $60,000 and the account has $84,000, the interest has to be the difference in those. Now let's turn our attention to the other variables in the formula. And there's also new names that are used in business for this situation. However, the point is we have an annuity. We're going to be making regular payments into an account, earning 6.6% compounded monthly. And we're going to have this sum of money in 5 years. So that is the future value of our payments. The term sinking fund is just a word that's used in business to mean what we just said. You're putting money into an account in order to achieve a sum of money later. However, it's still the same formula. And this formula is on the formula sheet. You don't need to memorize it, but here's what we need to make sure we can do with it. Put all the numbers in the right spot, and then do the calculations appropriately. We need to do this calculation and this one. And again, I can do those individually, assign them a letter on my calculator, and divide the letters instead of the numbers. And so solving this, and then taking my calculator and multiplying that bottom one, 800,000 times the K that I stored divided by the J, this is the sum of money that we need to deposit each month. The last one is how long will it be? Same formula. Substitute all the numbers into the formula. Now, finding the T here is quite a chore. I'll go through this with you. We need to divide out that 200. To make this a little easier to deal with, we're going to compute these numbers and give them a letter. So on my calculator, the 7,000 divided by 200 I'll call I. The other one is J. The bottom of the fraction is K. So this is what my new formula would look like with the I, J's, and K's. Now this is a little easier to deal with without all those big ugly numbers. I'll multiply both sides by K, add 1 to both sides, and then convert this into logarithms. The base is J. The logarithm is the exponent, which is T times 12. And then the other number is I times K plus 1. So there's the proper conversion to logarithms. We can type that on our calculator on a TI-84 new operating system. You can type it just like it looks there. Or we can divide the logarithms. Now I've used my TI-84 so you can see how I type that. And then we need to divide that number by 12. That's what we were looking for. Now again, the time is in years.